Hello, Brandon here. Thank you for taking the time to watch my video. I live in Penticton, British Columbia, which is one of only 2 cities in the world that is surrounded by 2 lakes, and therefore there is a lot of boats. I was commissioned to make this sign for a houseboat, and this is the story of the mothership. Like most projects, it starts off on the planer. The raw material for this was 8/4 hard maple. After several passes on the planer, I got it down to 1.5 inch thickness. After the board was planed down to the thickness, I took it over to the table saw using this straight edge ribbon guide to get one edge nice and straight. In the video you can see just one pass, but I actually took 2 to help prevent burning on the maple. After I had one edge nice and straight, I took it out of the jig, flipped it around, and made another pass to get my overall width. After everything was cut to width on the table saw, I went over to the miter saw, marked out my length, made a quick mark with the square, and then using several passes to help prevent any burning or any twisting as the tension released, I cut through it on the miter saw. After the board was cut to length, it was time to go to sanding. And this is everyone's favorite part of the project. Especially with hard maple, it takes a lot of sanding. Anytime I'm doing these projects, I always like to mark down my lines so that as I sand, I can see if I'm getting nice even wear. After doing both faces, I stood it up. And as you can see, when it was right on edge, it was really wobbly, so I decided to clamp down my clamp, and that made it much more stable. Once everything was sanded, it was time to do the Shou Sugi Ban, or roasting of the board. So I did pre-chamfer all the edges, and then using the Bernzomatic torch with the yellow map fuel, it's just going nice and slow to get an even char. You're really trying to avoid overburning one area or underburning another. This process takes a lot longer than you would imagine. You can play around with how much you roast the wood, and that will give you a different surface finish. I was just going for a nice even black so that once it was carved away, there'd be lots of contrast to the original maple. After the burning was done, I came back with a Scotch-Brite pad to wipe off any of the charcoal bits, any of the burnt bits. This did not work very well and it ended up just making a big mess. After this project, I've used a brass brush and that works a lot better. You'll hear some people telling you to spray it down with water. I find this causes the board to warp more, so I just let it cool down outside. After everything was cooled and wiped down, I loaded it onto the CNC, and you can see here it's going down with the 1/4 inch end mill, taking out the vast majority of the waste material. This was all programmed on Vectric V-Carve, which makes it a breeze to not only design, but also to simulate so that you know exactly how long it's going to take and what the overall design is going to look like. After the 1/4 inch end mill is done, I then switched out to the 1/8, and this is going in to clear up as much of the waste as it can. This drastically saves your time compared to doing everything with the 1/8 or everything with the V-bit, and you'll get a better surface finish as well. After the 1/8 end mill was done, it was time to switch over to the 60-degree V-bit. My overall depth on this was 0.2 of an inch. I didn't want to go deeper than that because the epoxy I was using is the Epoxy UV epoxy, which has a max pour depth of 1/4 inch. So if I would have gone deeper, I would have been risking having bubbles or the epoxy not curing. But if I didn't go deep enough, then I would have lost a lot of the depth and contrast between the burnt wood and the original maple wood. The carve in total took just over an hour to complete. Once the carve was done, I took it off the CNC and cleaned up any of the fuzzies with a brush, and then I applied a seal coat of epoxy. The point of this is to capture any bubbles that are going to come out of the wood as the epoxy is curing, and then that way when you do your deeper pour, you won't get any bubbles trapped. This is especially important over the charred wood, as I found the charred, for whatever reason, holds a lot of oxygen and releases it right as your epoxy is curing and you think your final project's going to be good, to find out that you're just full of bubbles. So after this seal coat, I let it cure for about 6 hours, and then once it was still tacky but firm enough, I then performed a complete flood coat to seal up the entire pocket. And here you have the finished goods. Thanks so much for watching. I hope you enjoyed it.